So we are jumping into part 2 of our discussion on compound events. We talked about independent events and how those events are independent of each other. One event does not affect the other event. Today we're going to talk about the second type, which is called a dependent event. And maybe you can guess by the word, and maybe you can guess by your definition of independent event, that dependent events, one event does affect the outcome of the other. One event does affect the outcome of the other. So we're going to look at a couple examples today, and I'm hoping that you see that they do look pretty similar in our process here. We're just going to have to really think about what each question and scenario is talking about, but you're still multiplying the two events by each other because they're still compound events. The scenario just reads a little different. So in this first example, it looks very similar to one on the front of this page. I just changed the question ever so slightly. So you see that, again, we're selecting a card at random from these mathematics cards below. But here in bold, you see without replacing the card. So we're drawing a card, and then we're not putting it back in the bag that we're drawing from, but we're still going to draw a second card. So we're just going to process and think about that a little bit. Just what does that mean for my different probabilities? So starting here with example A, we're going to find the probability of pulling an H and then an I. So the first time we pull our first card, so for the first letter here, H, we have all of the letters in the bag. So we counted that I believe there were 11, 3, 4, 5, 6, 7, 8, 9, 10, 11, and only one of them is an H. So that first probability, the probability of pulling an H, is going to be 1 out of 11. We're going to multiply it by the second one, but this time we're about to pull an I, and because of this statement right here, we didn't replace the H. This card no longer is in the mix. So when we go back and count, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're down one card. So out of those 10 cards remaining, only one of them is an I. So this new probability is going to be 1/10. So you see that this denominator goes down by 1 because we aren't putting a card back in the basket. We're going to continue to see that pattern as we go. But again, we're going to multiply these numbers. We just go straight across. 1 times 1, 11 times 10. We get 1 out of 110 for that probability. When we look over here at example B, and I'm going to erase just what I was drawing up here because our scenario has now changed. All of our cards are back in the bag, so we have 11 cards to start. And this time, we're starting with the letter M. So we're pulling the letter M out of the bag, and we counted that there's 2 M's out of the 11 cards. So that probability is 2/11ths, and we're going to multiply it by the probability of pulling a T. Now here's where it gets a little tricky. We wanted to pull an M the first time, but we only drew one card. So again, we only are down one card now. Whether we pulled an M or we pulled a different letter, we're only down one card. So this 2/11ths, we're then multiplying by what the chances are of pulling a T, but again, our denominator is down by 1 now because we pulled one card. And out of these 10 cards that are remaining, we still have 2 T's left in the mix. So this will be a 2/10ths probability. And I talked already about how when you simplify before you do the multiplication, it makes your life a little easier here at the end. So I'm going to do that again. This 2/10ths I know can be simplified. So I'm going to rewrite the problem. 2/11ths can't be simplified, but I know that 2/10ths can be simplified to 1/5. So if I do that simplification now, I know that my final answer will be in simplest form. 2 times 1 gives me 2. 11 times 5 gives me 55. So 2 out of 55 is my probability for this compound event. Let's look down at example number 2. Again, very similar to one that we saw on the front page. We have a bag that has 3 red marbles, 4 white, and 1 blue. We draw a marble out of the bag, and then again you see these words, without replacing it, you draw a second marble. So again, we're going to notice that our outcomes or our total options is going to change a little bit. But again, our first step is to add all of these numbers together. We have 8 total marbles to start. So in scenario number 1, it says, what's the probability of drawing a red marble? And since all of the numbers are in the bag, we have 3 red out of 8 total marbles. But now the question says, what's the probability the second event is drawing a white marble? And because we did not replace the marble we drew at first, my denominator is going to go down by 1 again. We now only have 7 marbles, and out of those 7, we're assuming that 4 of them are white. So 3/8 times 4/7, neither of those can be simplified, so I get 12 out of 56 down here at the bottom. 12 out of 56. I can simplify it now in this state because I now have 2 even numbers, and I can get 6 out of 28, which simplifies one last time to 3 out of 14. So 3/14 will be my final outcome or probability for this event. So now we're going to look at question number 2, which says, what's the probability of pulling a blue marble and then another blue marble? So again, we're starting with all the marbles in the bag, and we see that there's only 1 blue. So the probability of drawing a blue on the first round would be a 1 out of 8. But then, here's where it gets a little trickier. Our denominator goes down by 1 because we drew one of the marbles out of the bag. But if we wanted blue on the first try and we got blue on the first try, how many blue marbles are still left for us to draw? There was only 1 in the bag, and if we picked it that first time, our chances now are 0 out of 7. And so when I multiply these numbers across, we know that anything times 0 is 0. So this will be 0 out of 56, or just 0. This is an impossible event. We can't draw a blue marble twice when there's only 1 blue marble in that bag. So my final example that I'm going to walk through with you before you try some on your own, we have a deck of cards. You draw a card, and then we see these words again. Without replacing it, you draw another card. So before we start, we got to recall how many cards are in a deck. We talked about this in class already. There are 52 cards in a deck, 4 different suits, and 13 cards in each suit. All of that will be pretty important when we talk about the outcomes for these different scenarios. So example number 1 says, what's the probability of pulling a jack and then a 5? So we have to think about how many of each card are in a deck. We know that they're jacks. There are 4 jacks, 1 of each suit, out of the 52 cards in a deck. And we know then that on the second round, we have to decrease our denominator by 1 because we already drew 1 card from the deck. So we now only have 51 cards in the deck. What are the chances that we're going to pull a 5 out of those cards? And again, there's 4 5s in a deck of cards, 1 of each suit. So we have 4 out of 52 for the first event. And then because we didn't replace the card, we have 4 out of 51 for the second event. And we're going to multiply them like we always do together. These numbers are pretty big, and we could simplify this 4 out of 52 down, but I'm just going to multiply as is for now. We get 16 out of 52 times 51. I get 2,652. And this is what I mean by once these numbers start getting bigger, it really is nice to be able to simplify it before we do any multiplication, because now we need to go through the mess of simplifying it in this state. I know these are both divisible by 2 because they end in even numbers, so I'll start there. 16 divided by 2 is 8, and 2,652 divided by 2, I got 1,326. But these also both end in an even number, so I know I can divide it by 2 again. So down here, I'm going to get 8 divided by 2 is 4. 1,326 divided by 2, I got 663 as my final answer. Then last but certainly not least, we're going to look at just 2 suits. So what's the probability that we're going to draw a spade on the first go-round? Well, because there are 4 different suits, there's 13 cards in each suit, so I have 13 out of 52 cards are spades, and I need to multiply that. Again, I'm not replacing that first card that I draw, so this denominator goes down by 1, but there's still 13 hearts in that deck. There's 13 of each card. So this time I am going to simplify before I multiply. I know that 13 out of 52 is 1/4 if I divide them both by 13. And that I can't simplify in my second one, so I'll keep it as 13 out of 51. But I'm hoping that means I won't have to simplify here at the end. So I multiply straight across. 13 times 1 is 13. 51 times 4, I got 204. And I know that 13 is a prime number, so this would be my final answer. 13 out of 204. So that's a little glimpse at dependent events. Hopefully you saw the pattern. Just every time you do the second event, that denominator just gets decreased by 1 because you're not putting in that other card or whatever you were pulling out of a bag, whatever scenario is talking about. So that is the end of these notes. You can move on in your agenda to your next assignment.